Yeah. Can you hear me? Thank you. I hope you can see the screen too. Thank you very much. Yes. Yeah. Today, inshallah, we are going to discuss two sessions over here. That is stacks and queues. So two topics are to be discussed in today's class. That is stack and queues. This will help you to solve your TMA also. Okay. As we all know, the TMA date is coming near, so we need to cover up as soon as possible so that you can solve the TMA. So in this regards, today we are going to discuss stacks and queues. Now I'll start from the stack. Before I start, I just want to confirm that you hear me well and the screen is clear to you. Yeah. Okay, thank you very much. Yeah. So let's start with the stack. First we'll see the abstract data type. Abstract data types, they are nothing but a collection of data and the operations that can be performed on that data. Okay, for example, a collection of numbers and the operation that can be performed on the numbers. A collection of names and the operation that can be performed on the names, or this a collection of strings, operations that can be performed on the string. A stack is one of the type of abstract data type. Stack is one of the type of abstract data type. Now how the stack follows is the insertion of the data and the removal of the data, okay, into the stack. Okay, before that, you see here the given is a stack over here. This is a stack. Over here. Now it's an abstract data type where you can have a collection of data. A collection of data. Here we took a collection of numbers. a collection of numbers, and we have some operations on that data, operations on that data. Now here the stack retrieves the elements in a reverse of the order they were added. Okay, now before that, let us see here what is a stack. The formal definition for the stack is: a stack is a data structure in which only the top element can be accessed, and it is a collection based on the principle of adding the element and retrieving them in the opposite order. Adding the element to the collection and retrieving in opposite order. Now how it will be? For example, this is a stack. You add the elements. First you add, for example, add 1 to it, then add 2, add 3. 3 elements are added. Now if you want to remove the elements or take the elements from the stack, then it is in the reverse order. First you take 3, then you take 2, and then you take 1. Okay, first it comes 3, 2, 1. So the insertion and the removal is in the opposite order. This is said as last in first out, LIFO. Last in first out. The element which goes in the last will come the first out of the stack. So here I'll redraw again. If this is to be considered as a stack, so you add the elements to the stack. For example, 1, 2, 3, 4. 4 elements are added. Now this is the topmost element of this stack, and if you, this is which is went last, I mean which is added last, and the first to come out is the last element. First it will come 4, then it will come 3, then it will come 2, then it will come 1 out of this stack. Okay, now this is what it's given over here. A stack is a set of elements, okay, in a fashion of LIFO, last in first out, in LIFO fashion, last in first out fashion. Now here there are different operations can be performed on the stack. Those are push, pop, and peek. Push, pop, and peek. Now to understand these operations, first understand the pointers in this stack. There is a pointer called bottom, which is the first element which is inserted is the bottom of this stack, and there is a pointer called top of this stack, which is the last element which is inserted. So always the elements are removed from the top. Okay, so we have a pointer top, we have a pointer bottom. So here in the stack, the operation push, pop, and peek are done. Push, it means pushing an element or adding the element to the stack. Push, it means adding element to the stack. Pop, it means removing the element from the stack. And peek, it means verifying the top element without removing, or checking the top element without removing, or you can say verifying the top element without removing it. Whereas pop will remove the element from the top, and push will add the element to the stack from the top. Now elements are sorted in order of insertion. How you insert, based on that elements are kept in the stack. So if you insert, for example, if this is your stack, you insert first 4, then 3, then 2, then 1. So it will come in the order of insertion. Okay, for example, in another stack you insert 3, then 4, then 2, then 1. So it is sorted in the order of insertion. How you insert, accordingly it will go and stored in the stack. Now in the stack we do not need to think about the indexes. Okay, that is, as we think in the array, we cannot the index 0, 1, 2, 3, there is no need to think of indexes, and client can add, remove, examine the last element added from the top pointer. So any user can see what is the last element added, or can add the element, or can remove the element. Okay, that is adding the element by push and removing the element by pop, and examining the topmost element by peek. Basic stack operations are push. Push is nothing but to add an element to the top of the stack. Pop is nothing but remove the top element of the stack. Peek is nothing but examine the top element of the stack without removing. It will not remove. So here the conceptual view of this stack given, the top of this stack is this one and the bottom of this stack is this one. Okay, and this is the stack with these plates, or with these elements you can say. Now if you want to add the top of this stack, the addition is done on the top of this stack. New object is added to the top of this stack to give a new stack with a new top. Okay, the top pointer is moved one up. क्यों ना Okay, so here a new top, the top pointer is updated to the new top. Okay, the topmost object. Now let us look into the conceptual view of the pop, that is removal, pop function, that is removal of the top of the stack. So what you have to do is you have to reduce the top of the stack to -1, that is the new top is set to the, you have to if you want to remove the topmost object, then reduce the top -1 and the topmost object is removed with a new top. Stack operations again over here, push, pop and peek. Push will add an element as I told before. Pop is to remove the topmost element and it will return what is the element removed. Okay, for example, if this is a stack S, 1, 2, 3, 4, the top is 4. Okay, let's say the name of this stack is S. So S dot pop will remove the topmost element from the stack and it will return 4. It will return the value 4. So and the new stack will be 1, 2, 3 and top is on 3. Top is on 3. Peek will just return the topmost element without deleting the topmost element. Now it is not legal to access any element other than one that is in the top. So always in the stack we access the element from the top. We access the element from the top. So these are some operations of this stack. Now before moving, if you have any question about the stacks, the concept of this stack, is it clear to you? Thank you very much. Moving ahead. Now here is an interface for a stack. Interface is nothing but I think most of you have studied Java, Java in which you have studied the interfaces. So here the interface is nothing but it's a class. It's like a class with a variables and the functions or the methods without the implementation. Without the implementation. So if you see this interface, you have a function called pop, you have a function called peek, is empty, size, make empty. But there is no implementation for this method. Implementation in the sense there is no code for these methods. There is no code for this method over here. So that's why it is called as an interface. So interface is nothing but a class. Okay, it's a class type in which all the methods or the functions are not defined. They are declared but not defined. Okay, and all the variables declared inside the interface are by default final variables, that is constant variables. Now you see here there are functions of a stack. There is a pop function, there is a peek, there is a is empty, there is a function called size, make empty. Okay, pop function is to remove the topmost element and it will return the topmost element. Peek will just give you what is the topmost element in the stack. Is empty will check whether the stack is empty or not. It will return true if the stack is empty, otherwise it will return false. Size will give you the number of elements in the stack. Make empty will make the stack empty. There is another method to be added over here is push. Push will take an argument as an object and it will push the element into the stack. Now an interface basically is a kind of class. It contains methods and variable without implementation, as I explained over here. So the general definition is given here. Therefore it is the responsibility of the class that implements an interface to supply the code for the methods. Whichever the class is using this interface or implementing this interface should write the code for these methods. So stack can be implemented either by using arrays or by using linked list. Okay, we have studied the linked list in our previous class. So here the stack can be implemented by either by arrays or by using linked list. Okay, but in this course we are going to use arrays to implement the stack. We are not going to use the linked list because we are very much familiar with the arrays. We have studied the arrays before in this course, and also we have studied the arrays in the other courses like M105, M257 and other courses too. Now here the class will be something like this: public class array stack implements StackADT. Now this StackADT is interface what we have over here, StackADT. Now it means that this class array stack should write the code for all the methods of StackADT, because StackADT is a interface. It has unimplemented methods, just a method declaration. That for that methods the array stack class which is implementing this stack interface should write the implementation, the code for all the methods. Now here public class list stack implemented StackADT. Now there are two ways is shown over here: the implementing the stack by using arrays and by using the list. Stack limitations: we cannot loop a stack as we do for the array. Okay, we cannot go a stack reading the elements of the stack one by one as we do for the array, because we have no access to the elements except only to the topmost element of the array, I mean of the stack. So we cannot, if you want to access the last element of the stack, for example the stack is 1 2 3 4, if you want to access this, then first you remove this element, then top will be over here, then you remove this element, then top will be over here, then you remove this element, then it comes top here, then you access this either by peek or by pop. If you want to remove, by pop. If you want to just see, by peek. So here it means that we cannot traverse without removing it. So to remove this we use pop. Okay, so that's why we cannot write a loop for the stack. So as I told, instead you pull the element out of the stack one at a time. So common idiom is pop each element until the stack is empty. You take all the elements one by one until the stack becomes empty. So here it can be done something like this: while not of s dot empty, while the stack is not empty, do whatever you want to do with the topmost element and pop the topmost element. Now what happened to my stack? Suppose we are asked to write a method max that accept a stack of integers and return the largest integer in the stack. So this is the given code. But this one, before looking into the problem in this code, let us study this code. Here the question is that write a method max that accept the stack of integers and return the largest integer in the stack. For example, let us say this is a stack. The bottom element is over here 1 2 3. Let's say it is 4 2 3 1. Okay, so the top pointer is here. This is the topmost element is 1. Okay, now our method, this is the stack called S. So here we are passing the stack to the method called max, and we want to find the largest element or largest integer in this stack. So how we can do is, first we'll take the topmost element. Okay, so let us consider that maximum value or the maximum integer, or let us take this max value so it will not be confused for you. I'm sorry, I'll rewrite this one. 4 2 3 1. This is the topmost element. This is the stack S. Now first we'll pop the topmost element and assign to a variable called max value. So max value will have the topmost value, that is 1. Okay, the next is we'll put that in a loop while S is not empty. Not of S dot is empty. It means that while S is not empty, int next is equal to S dot pop. Now here we already took the first element. The top is moved to 3. Okay, now we are taking into a variable called next S dot pop will return the element and remove this. Okay, remove number 3. The top is moved to the next element. Okay, now after that max value is equal to math.max of max value comma next. Now it will calculate the maximum of 1 and 3. It is 3, so it is assigned to the max value. Then again it will loop again to the while and check if stack is empty or not. Still we have 2 more elements. The stack is not empty. It will say next is equal to S dot pop. pop will remove the topmost element, which is 2, and assign to next. Then it will say that max value comma max value is 3, next is 2, which is the maximum 3 is assigned to the max value, so it will be over here, and the top is over to the first element because we already took number 2. Now it will again go to the loop and check is empty or not. It is not empty, true, then pop into the next. Okay, pop will remove 4 and return 4 over here. Yeah, math.max is a built-in function from the math class which will calculate the maximum of two numbers. Now after that it will say math.max of max value comma next. So what is the maximum over here? 4. So 4 will be given to the maximum value. Again it will loop, and now the stack is empty because you popped the fourth element. All the stack is empty, not of stack is true, so it will come out of the loop and return the max value. Max value is 4. Now here this function will return the maximum value, but what happened to the stack? We have used a stack S and we see the stack is empty now. All the elements of the stack are removed. The algorithm is correct to calculate the maximum, but what is wrong with the code is it will remove all the elements of the stack and the stack is empty. You don't have all the elements of the stack now. So what if I want to calculate the maximum value of my stack and still I want to keep that stack? I don't want to delete the elements of this stack. So how we can do that? How we can do it? So do you have any idea that how we can save our stack? Because in this code we have seen that our stack is empty now, so we cannot keep the stack. Now peak will always give us the top element, it will not go to the next element. Return the stack. Even if you return the stack is empty. The stack is empty now. Even you remove it, the stack is empty. Doing top minus 1, it will not affect anything. If you do top minus 1, it will go till the end. Every time we do pop, when we do pop, it will remove the element. So no more idea how we can save our stack? Okay, let me ask you a question. If you want to format your mobile, or if you want to format your computer, what you will do with your files? For example, you want to format your computer, or you want to keep a copy, keep a backup. Yes, we'll keep a backup of it, right? Now here, the same fashion, we can keep a backup of our stack. We can keep a backup of our stack so that the stack will not be destroyed. Okay, will not be the elements of the stack will be kept remains with us by even we do the pop operation. So here the next slide will show us now how to keep that backup. Okay, now here in the same function we'll create a new stack called backup stack. When you do the pop, when you are doing the pop, now for example this is your stack S, in which you have 4, 2, 3, 1. This is your topmost element. Right? Now let us, you have created a new stack called backup stack. Okay, now backup stack is empty, we did not insert any element. Now our code says that first take the first element into the max value by doing pop. So when you do the pop, when you do pop over here in this point, it will take 1 from the stack and update the top to the next element, and this one is assigned to max value. So your max value has 1 now. Okay, now let us insert this max value into the backup, because you have taken this one. So we say that backup dot push max value, backup dot push max value. The max value will be in the backup stack, because the push will insert the element into the backup stack. The next we have a for loop, a while loop. We'll check whether the stack is empty or not. It is not empty. Then we pop the next element, that is 3, into a variable next. So there is a variable next. We'll have pop the next element 3, and the pointer is now at the second position. Now here top is 2, next is 3. Now we have taken the next. Now we need to insert again this next value into the backup. So we say backup dot push of next. We'll insert the next value into the backup 1. Okay, now this will calculate the maximum value. Maximum is 3 now here. It will go to the loop again, take the s dot pop, take this element 2 into the next variable, push the next by here, push the next into the backup stack, and then calculate the max of max value and next value. So it is 3 is the maximum, so max will remain 3. Again it will go to the loop, check whether the stack is empty. It is not empty. Next is equal to s dot pop, the last element, so will be 4 is given here. Now stack becomes empty. Before that it will calculate the maximum of max and next. So maximum is 4. I'm sorry, before calculating maximum it will push. Okay, now here the top is the topmost element, and calculated the max. The max is 4 to return the max. Now you see we have the elements of the stack. We have the elements of the stack in backup, but still the two stacks are different. Stack S and our stack backup is different. Now what is the difference over here? Yeah, it is just not opposite, it is just in a reverse order. It is in a reverse order. The elements over here are 4, 2, 3, 1, and the elements over here is in a reverse order 1, 3, 2, 4. Okay, now what we can do it to bring it to the original stack? Now we have to restore the S, our S which is empty now. Our S which is empty now. Yeah, return it to the S stack by doing the same pop operation. Okay, so what will do, while backup is not empty, S dot push of backup dot pop. Yeah, pop and push. S dot push of backup dot pop. Backup dot pop will take the element, will give over here 4, and 4 is pushed now here in the first position, and it will repeat again. It will loop, 2 is removed, 2 is pushed over here. 3 is removed, 3 is pushed over here. 1 is removed, 1 is pushed here. Now we got our stack right as it is in the beginning. Okay, this is how we can restore our stack while doing the operations. Now, array implementation of the stack, as I told in this course, we are going to use the array implementation for the stacks. To implement a stack, items are inserted and removed at the same end, which is called the top of the stack. So in the array, we are going to insert the element from a single end. Efficient array implementation requires the top of the stack to be towards the center of the array, not fixed at the one end. To use an array implement a stack, you need to both array itself and an integer to point the top, or to keep the count of the elements of the stack. Count of the elements of the stack. Now we can use array implementation of the stack. There are two figures given over here. We can say the top of the stack is this one and the bottom is 3, or we can have another implementation as top is this one and the bottom is 0. Now what is the relationship between the arrays and the stack? Now here we all know, we have studied the arrays. Arrays are nothing but they are one of the way to keep a collection of items. Now the concept of a stack is same again. It is a collection of items. Okay. Now if you want to write a stack, then you can use arrays. You can take the help of the arrays to write a stack, or you can take the help of the linked list to write a stack. Now here we are taking array to write a stack or to implement a stack. Okay, I hope it is clear to you. Welcome. So here we need to keep track of the number of elements or the count, and we need to keep track of the top of the stack. Now here in A, the first location is the top of the stack, whereas in B they refers to the first location as the bottom of the stack. So either of the way we can do it. Now let us take this one. Consider this as a stack, an array implementation of a stack. And if we want to push an element to this one, we'll see the top is 3. Top is given as the index. Top is 3. Now if you want to insert, you increment the top, which you'll do top plus 1, or you keep the count. Count is how many elements? There are 4 elements. Now increment the count. Either you increment the top if you keep track of top pointer, or if you have count pointer, then you increment the counter. So if the bottom of the stack is location 0, then an empty stack is represented by top is equal to -1 or count is 0. Okay. If this is the bottom of the stack, then top 0 is this element. Top of -1 is, it means that the stack is empty. Or count is 4 elements, 0, 1, 2, 3, 4. If count is 0, it means this is an empty stack. To add, to push, that is push an element. So either you increment the top and store the element on the stack of top. As I told, you increment the top becomes 4, and then you store the element on the stack of top, that is stack of 4 is equal to, let us say, 55. So at this point 55 is inserted in this position. Or you store the element in the stack of count and increment the count. Okay, now here you see the count is 4. Now stack is an array. Stack of 4 is equal to 55. So this stack of 4 is this one, 55. Now you increment the counter, count plus plus, or count is equal to count plus 1. Now count becomes 5 here. So count becomes 5. Okay, and the element is inserted. Add 67 to the stack. Now here there are two ways, as we discussed. Top, either you increment the top and assign stack value to the top, or you increment the counter and put the value in the stack. You increment the counter will be now 5. Now popping an element, if you have this stack as an array, then if you want to pop the element, either you do minus minus of top, decrement the top, or you decrement the count. Get the element from the stack of top and decrement the top. Or decrement count and get the element in the stack of count. So for example, here top is 3, we want to remove 44. So what do you do? First get the element stk of top. Stk of top is now, top is 3, that is 44. This will give you 44. Now decrement top minus minus, top will go to the its previous location, okay, by removing this element. Or you decrement the counter first, that is count minus minus, count becomes 3. Now take the stack of count, stk of count is 3 is over here, take this element, okay, and the count remains 3. So count 3, it means 3 elements, okay. After popping, the top will be 2 and count will be 3. So when you pop an element, do you just leave the deleted element sitting in the array, or you need to remove that element? Okay, so that what happens to this element? So it depends. If it is an object, you need to set this to the null. If it is an object, if it is not an object, it is an integer, you need to set this to 0. If it is a double value, you need to set to 0.0. Because when you set this one, then that object will be available for the garbage collector to free the space. Now here, after removing, your top element will be 97, top will be 2, our counter will be 3. Now here we will see how we can implement the concept what we have studied by using the array, implementing the stack by using the array. First we use an array, the array, to hold the elements or the objects, okay. Then we use a top variable to point to the topmost element of the array, out of the stack. Initially top is -1 because the stack is empty. Push operation will increase the top plus plus, and push the element in the array of top. Then pop element will check whether the top is not equal to -1, because if top is -1 there is no element to pop. So it will first check whether the element is -1 or not, the top is -1 or not. If it is not -1, then it will decrease the top to -1, okay, reduce it by -1. Then peak operation will check whether top is not equal to -1, because if it is -1 there is no element to display. Otherwise it just return the element at the top, because it will just display the element of the top. Is empty will make the top -1. It will check whether the top is -1 or not. If it will return, if the top is -1, it will return true. If not, it will return false. Now here is a stack implementation. Private object, the array. The object can take any value. It can be private int the array, double the array. So object can take any value, int or double or any other data type. Int top will give the topmost of the array. Default capacity as final 10. So we are setting the capacity of the stack to 10. Public stack, we are creating the stack over here. Stack is equal to the array. This is a constructor in which we are creating the array. Array is equal to new object of default capacity. So we are creating an array of, by name the array, with a value 10. So we can store 10 elements in the array, and we are assigning top to -1, saying that the stack is empty. Public boolean is empty method returns top is equal to -1. It will check first whether top is -1. If top is -1, this will return true, so the true will be returned. If top is not -1, it is not equal to -1, this will return false, and false will be returned. Okay. Make empty will just set top to -1. When top is -1, it means the stack is empty. Peak is just to display the topmost element of the stack, so it is return the array of top. Now what if it is empty? It should say stack is empty. So here, if is empty, if it is true, then throw a new underflow exception, stack is empty. Underflow, it means the stack is underflow, there is no elements in the stack, so it will return stack is empty. We will see this exception. It is user defined exception. We will see in the next slide. Object of pop, it will return the topmost element and do top minus minus. So the array of top minus minus. So first it will return the topmost element, and then it will decrement the top by -1. This is something equal to the array of top and then top minus minus, or minus minus of top. They are put in one statement as the array of top minus minus. Again, it also check for the is empty or not, because if you trying to pop the element and the stack is empty, then it should throw the exception saying that stack is empty. Push object of x, it means insert the object into the stack, where you increment the top. Now here you can insert directly by incrementing the top. Plus plus of top, it means increment the value of top and then assign x to the array of top. It is something like top plus plus, increment the value, then you say the array of top is equal to x. So these two statements are put in one thing. Now what if the array is full? I mean the stack is full and still you want to push the element. Okay, either you can say that the stack is full, you can return an exception, or you can double the array. You just double the size of the array and then you insert the stack element. You double the size of the array and then insert the element. So we need to write a function double array to double the size of the stack. So here is the function double array. Object new array, we create a new array which is the length of the current array into 2. If the length is 10 into 2, that is 20. The size of the new array is 20. We take all the elements of the array into the new array of I. Okay, and then we assign the array to the same new array. So for example, this is the new array and this is the array, the old one. Okay, now you are inserting all the values of this old array into the new array. So here it will come, because it is double in the size, it will go half of the part and is assigned. Now the new array has the elements of the array and there are some blank spaces. Okay, now we need to assign this, the pointer of the new array to the new array. Pointer of the array to the new array by removing this one. So this will be removed by this statement. The array is equal to new array. The array is assigned to the new array. New array now is the array is pointing to its previous element plus the blank space. And then after that you do the push. Then underflow exception, what we are defining over here, that throw new underflow expression of the message. So it is it extends the runtime exception, public underflow exception, string message, super of message. So it will send this message, that is stack is empty, to its super class, and it will display over here the message as stack is empty. So this is the stack implementation using the array. So here you no need to write this implementation. The implementation is given to you and it is available in the LMS in the Word file. Okay, so if you want, you can go back and look the Word file over here, the stack implementation. Okay, you see that the code is available. So whenever you want to use it, you just copy and paste this code. Okay, write the names. You have the main method over here. You can create the stack here. Okay, and do all the operations of the stack, whatever you want. Okay, copy and paste this code into a NetBeans and you can run this one. Okay. Error checking, there are two stack errors can be occurred. That is underflow, that is you are trying to pop the element or you are trying to pick the element and the stack is empty. This is called underflow error. And overflow error is you are trying to push the element and the stack is full. Okay, so for example, if this is a stack S, this is a stack S, the stack is empty now, top is -1. Now still you are saying s dot pop. Now at this point the underflow error comes saying that the stack is empty or the stack is full. Here there are the elements in the stack, this is the top and it is full. Now you are trying to still say push, s dot push of 10 again. So at this point the stack is full and this error is called an overflow error. Underflow error can be cached by array index out of bound exception or you can create your own. Okay, overflow, you could do the same thing, say array index out of bound exception, that you are, or you can create a new array which will double the size and assign the stack to the new array. as we did here for double array. Now complete stack code is given over here over in the Word file which I showed you. You just need to copy the code, create a NetBeans project in which create a class. In that you copy and paste this code and you can run this stack. There are some examples of this stack. What you see here, in the same fashion you will get for your exams. I think it's available in your homework also. They will give you the stack, they will give you the code and ask you to do the operations or explain what is happening in the code or write the output. Okay. Now what is the given example here is, what is the output of the following operation if S1 and S2 are two stacks initially empty. So let us write first two stacks S1 this and S2. Let's say this is S1 and this is S2. Okay. Now here it is initially both are empty, so their top is -1. Their top is -1 because both are empty. Now here there is a for loop for int a is equal to 2, a is less than 10, a is equal to a plus 2, s1 dot push of a and s2 dot push of a minus 1. So here in the stack s1 you are pushing the value a starts from 2 and it will loop up to 10, incrementing every time by 2. So a starts from 2, 2 is less than 10, push 2 in the s1. Now this is your top and push 2 minus 1. 2 minus 1 is 1. 1 in the S2. Again it will loop again. A becomes 4 because it is a is equal to a plus 2. A becomes 4. Push 4 now and 4 minus 1, that is a minus 1, 3 in S2. Then a becomes 6. Now push 6 here and 6 minus 1, 5 in S2. A becomes 8, push 8 in the S1 and 8 minus 1, 7 in the S2. A becomes 10, 10 less than or equal to 10 true, push 10 and 10 minus 1, 9 in the S2. Now the top of S1 is 10 and the top of S2 is 9. Then a becomes 12, 12 less than or equal to 10 false, it will come out of the loop over here. Now here there is again a while loop while S2 is not empty. S2, the top is over here, it is not empty. Okay, not of S2 empty. System.out.print. Now here the output is printing now over here because there is a print. S2.pop removes the S2 9, it is 9 into S1.peak. Peak will just get this for 10 without removing. Top remains in the same position. So 9 into 10 it is 90. So the output here is first is 90. Then still now the top is at 7. S2.pop 7 into S1.peak. Peak is the last element. 10, 70. Again it will repeat 5. Now top is 5. S2.pop, pop will remove this 5. Will taken here 5 into S1.peak. Peak is 10. 5 into 10, 50. Yeah. Then the next will be 3. The next number is 3. 3 into 10, 30. Then next number is 1. 1 into 10, 10. And now the stack S2 is empty. So S2 not empty is false, it will come out. So what is your output is 90, 70, 50, 30, 10. This is the output. So before moving to the second example, is the first example clear to you? Thank you. Now let us move to the second example. You are given a stack. The following are the functions of the stack. Public boolean is empty, push and pop. Write double stack that take a stack S as an input and double the value of its elements in the same order, and the method should not return any value. You are only allowed to use the stack object in your method. For example, the stack was initially with the following items: 4, 3, 2, 1. Then after the calling the function, your stack should be with this item multiplying by 2, 8, 6, 4 and 2. So how we can do this one? This is your stack with the elements 1, 2, 3, 4, and this is your input S. This is your input stack, and you should print the output as a stack 2, 4, 6, 8. That every element is multiplied by 2 into 2 into 2. Now how can we do this one? Do you have any idea? What logics we can apply to do this? Okay, we create a new stack. Then push top into 2. Then loop. Yeah, what next? Restore into 2. No, I don't want the code, you just give me the idea. The code is not required. Just need an idea and a logic how you can do it. Anyway, you are very near. I think you got the idea. Yeah, we create a new stack and give it a name with some name. Let's say temporary stack. Use a while loop to loop the stack. Yeah, until the stack is empty. we loop the stack and take every element and multiply by 2. Yeah. Yeah, S, the new stack dot push of S dot pop into 2. Yeah, another while loop will take from the new stack and push it in the stack S. Yeah. Yeah, that's good. And the idea is, mashallah, very clear. So here we'll take a temporary stack. Okay, until the stack is empty, we pop the element and multiply by 2, and that element is pushed into the temporary stack. So your temporary stack will be, the first element is 8 because the first element to the popped, yeah, the first element to the popped from the stack S, because this is the stack S. Let us say this is the stack S, 1, 2, 3, and 4. Okay, S dot pop into 2, that is what is 4 is at the top. 4 into 2, 8. 8 is pushed into a temporary stack. This is temporary stack, and then top is here. This will loop until it is empty. So 3 into 2, 6, 2 into 2, 4, then 1 into 2, 2. Now the stack becomes empty. This loop ends and come out. Now you have 2, 4, 6, 8 in the temporary. Now pop from the temporary, your stack is empty here, that is S is empty here. Pop from here and push here. So it is 2, then 4, then 6, and then 8. Now it is your S. So it is S dot push of temporary dot pop. Okay. So that's good, and you have the idea of, with this you have the idea of the stacks and the operations of the stack, which is the most important part. Now if you have this idea, you can solve any questions related to the stacks. So with this we are done with the stacks. Now we'll move to the next topic, which is about the queues. Now you see the queues and the stack are very much similar, but they follow the different fashion. The stack, what we have seen, is in a LIFO fashion, last in first out, right? Yeah. uh, it does not mean like a stack, it means is as a stack, but it has some difference between the stack and the queue. In the stack you have seen, the stack, it is in the fashion of last in first out. That is, in any stack you insert the element in the last, that is 1, 2, 3. The first which is at the top is the first element to be removed. Okay, the last in will be the first to be removed. Okay, and you have the that is called push, and you have a pop, and you have a peak. Okay, pop will remove the element, push will add the element, peak will just give the topmost element. Now queues will follow the fashion of first in first out. First in first out, it is something like a queue in which you push the element or enqueue the element. NQ or add or push. We don't say push, we say sometimes add or we say NQ. NQ the element, for example, first you inserted 1, then you insert 2, then you insert 3, and the first element to come out is the first element what you have inserted. This is called DQ or remove. Okay, this is the difference between stack and the queues. The stack follows the LIFO fashion, last in first out, and the queue follows first in first out fashion. To understand the queue, it is very similar. I mean, it is like a queue you see in the supermarket, queue at the counter. You see at the sales counter, the ticket sales counter, which is a queue. So in the same fashion, in the networks also, yeah, we'll take the help of the arrays to write the queues. We can write in both by using arrays and by using a linked list, but here we'll discuss with the help of the arrays. So queues are the queues are used in many areas in networking to transfer the packets or the data from one computer to another computer in a queue fashion, or between a printer and a computer to print the documents in a queue fashion. Which comes first will be printed first. Now the definition of the queue over here is: queue is a data structure that can be simulate a list of stream of data. That is a stream of data. In this structure, new elements are inserted at one end, that is called rear, and the existing elements are removed from the other end, that is called front. So if this is a queue, this is a rear where you insert the element, and this is called the front, that way from where you remove the element. Queue store arbitrary objects, that is all type of objects like strings, integers, or any other objects. Insertion and deletion follow the first in first out fashion, that is called FIFO fashion. Insertion is done at the back, that is at the rear end. Insertion is done from here, and the removal is done from the front end. Main queue operations are NQ and DQ. NQ is nothing but inserting the element. Sometimes it is implemented as add, and DQ is removing the element. Sometimes it is implemented as remove. Okay. Auxiliary queue operation is front. Will give the what is the element in the front. What is something like peak in the stack, which will just display the element at the top. Front will just display the element at the front. For example, if this is the queue, you have 1, 2, 3. This is your rear end, and this is your front end. The front is the first element. When you say front function, it means it will just give you the first element. Okay, it will not delete the element. Size will give you a number of elements. What is the meaning of auxiliary? Auxiliary operations, it means the added operations. Here you have the main operations of the queue. Okay, and the other operations in the queue is nothing but the auxiliary operations. Is empty will indicate true if the queue is empty, otherwise it will return false. Length of the queue is the number of elements in the queue. Applications of the queue where the queues can be used: it can be used as a scheduler for controlling the access to the shared resources, that is maintaining a queue of printer's job. There is, for example, there is a printer connected in the network. There are many computers sending a print request. So which comes first request will be processed first. Simulation of real world situations. Telephone operators. In telephone operators, in a toll-free numbers, I think you have experienced this, that whenever you call a toll-free number, they'll keep you, sometimes they'll keep you in a hold so that they can finish the first call. So that means that they keep you in a queue. So you have to stand in a queue. Your call is standing in a queue. The first calls will be finished, then your call will be taken. Array implementation of the queue. This is done by using two pointers, that is the rear pointer and the front pointer. Okay, you can create an array called myQueue, in which we can insert the values from the rear end, and you can get the value from the front end. So here the rear is 3, front is 0. To insert, you set the rear to 4. You need to add the rear. So rear plus plus or rear plus 1. To delete, you set the value of the front to 1 by removing this element. You set the front, that is front plus 1, and you set this value to 0 if it is integers, null if it is any other object. Let us take this as an initial queue. After insertion, if you want to insert, increment the rear becomes 4, and after deletion, increment the front becomes 1. Now this is your queue. Now you see the queue, it does not start every time from the beginning of the array. So there might be element deleted from the beginning of the array, and your front is at the second position in the array, and you have the rear, which is the last element inserted. So notice how the array contains crawl. It means changes to the right as the element as inserted and deleted. No, suppose that we have an empty queue by name queue. Let us see what will happen after executing the following operation. NQ of 5. NQ, it means what is NQ? It means adding the element. So add 5 to the queue, queue will have the 5. Then NQ of 3, queue will have 5 and 3. Now this is 5 is the front element, 3 is the rear element. Then DQ, when you say DQ, it is nothing but removing the element. So DQ, it means it will remove from the front. So it will remove 5. So after DQ, it will return 5, and the Q is just 3. NQ of 7 will add 7 to the rear end. Now rear is 7, front is 3. DQ will remove the front element, remaining only 7. Front will just give you the front element 7. DQ will remove the 7, which is and the Q is empty now. DQ, if you want to again DQ, if it is empty, then it is error. Is empty will return true because the Q is empty. NQ9, NQ7 will add 9 and 7. Size of the queue is nothing but the elements in the queue. NQ3, NQ5 will add 3 and 5. Then DQ will remove the front element, that is 9, and the Q is 7, 3 and 5. So what are the operations? You have all the operation. It is Q, NQ and DQ, and you have also front is empty and size. So this is about the queue. The next we look into a circular queue. Circular queue is nothing but a queue that forms a circle. That forms a circle, which is given in this diagram. Yes, before this one. Yeah. Yeah, it is first in, first out. Okay. Yeah. First should be 3, not, yeah, it is 3. So where is the wrong here? Sorry. No, we deleted 3 here. See here, it is the front element is 3, you added in the step 4 7. So 3 and 7. So when you DQ, the front element is removed. Okay, so the front element is 3. 3 is removed and remaining is 7. Then you call the function front, will just display what is there in the front. It is in the 7, it will display 7. Right? Now first element and the first input both are same. Yeah, before and we are removing 3. See here we are removing 3, this 7 is still in the queue. See here, the 7 is still in the queue. The DQ will remove 3 because 3 is inserted first. So first come is first out. First in is first out. So remove is inserted before 7. Sorry, 3 is inserted before 7. So the DQ will remove 3 and remaining is 7 in the queue. Clear? Okay. Circular queue is something like this in which is in the form of circle. Now the circular queue, we can expect the front and the rear as, for example, the front over here and the rear over here in the first position. How come it is? It is like you are inserting the elements, okay, and deleting from the front, inserting from the rear. So you go on inserting from the rear end, deleting from the first end. For example, you have inserted up to 4, up to 4 element. Now you are inserted, you have from the 5th element, maximum is the 7 elements from 0 to 7 or the 8 elements. Now you want to insert again in the circular queue, you can insert from the beginning. Okay, that is in the circular queue. So it will come again over here 44, then 55, then if you want to insert now here, for example, 66, 77, and you want to delete 11, the front will go to the 6, 22, the front will go over 33. 33 you did, the front will come here. You insert more, will be added over here in the form of circle. So it goes something like this, in the form of circle. Front will move following the rear. Rear will be over here moving. So in this fashion, okay, this is called a circular queue. So elements were added to the queue in order of 11, 22, 33, 44 and 55 and will be removed in the same order. So we can use the front as front plus 1 modulus with the myq.length to get the front. Okay, now why we need to mod this one as given here, front plus 1 mod with the myq.length modulus operator. This operator will return you the remainder. I think you have studied this in M105 and in other courses also. This will give you the remainder. It means, for example, there is the length is 8, right? Okay, if it is 16 modulus 8, the remaining is 0 because it divides 2 times. 2 8 is 16, remaining is 0. For example, if it is 17 modulus 8, remaining is 1 because 17 modulus 8 will divide 2 times 16, remaining 1, which is the remainder. Now more in the same fashion, it is here front plus 1 modulus with myq.length. Okay, so here for example, it is, let's say the front is at the 5th position. Okay, 5 plus 1, that is 6 modulus with 8. 8 is the length of the queue. So what is 6 mod 8 is 6 itself. So your front has the 6th element. Your front has the 6th element. In the same fashion, the rear is rear plus 1 modulus q dot length. As you have the rear here 1, 1 plus 1 2, 2 more 8 is 2 only. So your rear is at the 2nd position or the 2nd element. Okay. Now if you delete the element, you add 1 to it. Every time you add 1 and modulus with myq dot length. Both front back indexes wrap around the array. Think of the array as a circle, as I explained you before this slide. Now detect what actions is done in each of the following diagram. Front is P, back is Q. Now here what the action is done? Can you tell me what action is done over here? Reminder of what? So Mr. Abdullah, it is clear to that the modulus operator will give you the remainder of after division. I think it is you have studied this in M105, in M131. Yeah, that's good. So here the add operation or the NQ operation. Okay. Then next, what operation is done to get this from this? It is again add. Yeah, the remainder of the back. Now here, what is the back? For example, if you take the index 0, 1, 2, 3, 4, 5, 6, number of elements are, the length is 7, right? Now your back is at the 6th position. Back is at 6th position. You add one more element. Now the element should go to the beginning because it is a circular. Okay. Now how do you calculate the pointer of the back to 0. It is, as I told, that is back plus 1 modulus with the length, plus 1 modulus with the length is 7. So it is 7, 6 plus 1 7, mod 7 is, what is the remainder? It is 0. Yeah, so it means it will go to the 0 position. Then what operation has done to get this one from this? It is in the example add. Now in this one is add. I am asking about this one. What operation is done over here? Yeah, it is remove the friend and remove the element P. Then we remove Q. We remove Q in this here and move the friend. Then we remove R and move the friend. Then we remove the S and move the friend pointing to the same value. Then we remove the front again, which is the last element, moving ahead the front. Now let us take the look into the full and the empty queues. Okay, when we add T, if there is a data in the first position, will it be deleted? No. See, we are moving from the back to the front as a circular queue. If there is a data from the front over here, it means there is a data over here. And there is a data over here. The stack is full. I mean, the queue is full. Okay. If there is a front data, there should be a pointer for it. If there is a data here, it should be front, not this one. So when the front and back is now, if you cannot add the element over here, so it says that the queue is full. We cannot add the element. The element is only added when there is a space in the queue. It will not override it. It will just add when there is a space. If there is no space, it is full. Okay, now here how to check the queue is full or not? If we can check by one condition, there are two ways. One of which is if the front minus rear is 1, as you see in this example, front is 5, rear is 4. Okay, if it is 1, it means that the queue is full. Okay, it means that the queue is full. If we are then to remove all the 8 elements, making the queue completely, it would look something like this. If you remove all the elements, okay, you go on moving the front, you go on moving the front. Okay, so it will go on moving it until it reaches again over here, and after removing this 88 it will move here. So empty will remain also 1. So we have a problem here that both 1, we don't know whether it is a full or not. If front minus rear is 1, now here the question is whether it is full or empty, we don't know. Okay, now the solution to this problem is keep a additional variable called counter. Okay, now if you see the real plus front, we can keep the here I'm sorry, we can keep an additional variable called count to keep track of the full or not. Okay, so if the number of elements of the queue reaches 8, then we say that the queue is full. Okay, and if the number of elements is 0, or it's a rear minus front minus rear is 1, we can say that the queue is empty. This solution number 2 here is, which is more efficient, is keep a gap between the elements, that is the last element, the front and the rear element. Keep a 1 element gap. Okay, with this we can identify whether the queue is full or empty. Now we can also implement the queues in Java. Okay, as we did for the stack, we write the interface called queue, in which we have to include the isEmpty, makeEmpty, getFront, add, remove. Add is enqueue, that is you are going to add the element. Remove is dequeue, that you are going to remove the element. Front will give you the element at the front, and makeEmpty will remove all the elements. isEmpty will check whether the queue is empty or not. Okay, it is implemented here. The class is implemented here, the queue class. Okay, this implementation is given for you. You don't need to write this code. It's given for you. It is there in the LMS in a Word file. You can look into that Word file. This is a queue implementation file. It's available in the LMS. You can look, all the complete queue is implemented over here. Okay, now what you have to do is you have to copy this code and paste it in the NetBeans. Okay, create a class and paste over there, and then you do all the operations over here in the main method. Okay. Now let us take some examples of the queue and see how we'll try to analyze these operations. Assume that Q1 and Q2 are queues. Q1 is currently empty and Q2 contains A, P and M, front to rear. Okay, there are two queues now here. Q1 is empty. Q2 has, this is empty. Q2 has A, P, M, front to rear. So it is your front, this is your rear. Okay, give the contents of both queues after doing the execution. No, it's not necessary to put in the two classes. You can put in a single class. Okay, it depends on how do you have this code. If it is given in two different classes, you put it in two different classes. Or you can do is create one class for all these operations, all these methods. Okay, and in the same package create another class for these throws, sorry, for this one. Okay, and in the same package case create another class to put this main. Okay, yeah, you can put it in three different classes, or you can put in two different classes. Okay, most probably inshallah I'll try. If I find some time, I'll record a video for this inshallah, that how this will work in NetBeans, and I'll show you the different all the operations of the queues and the stack uh, in the NetBeans. Okay, now here these are two queues. Answer the each part independently of other using the above initial content. Now first one is this is q1 and this is q2. Okay, as given. Yeah, this is your front and this is your rear. q1 dot nq of b, nq of b, so it will add b, and q2 dot d cube remove a, q2 dot d cube remove p, so it will be something like this, adding b to the q and removing from q to dq to dq, so one by one a and p. Now your front is m only. Then this is q1 and q2. Now nq of q2 dot front, this is q2, right? q2 dot front is this one, this is rear. nq of q2 dot front, it means take front and nq in q1. q2 dot dq, remove this one, now this becomes f, the front. q1 dot nq of c, add c. Then q2 dot nq of d, add d at the rear end. Okay, so it will be something like AC for q1 and pmd for the d1. So obviously this will become the rear, the d. Then q1 dot nq of q2 dot front, q2 dot front is this one, this is q2, this is q1, so it will take q1 dot nq of q2 dot front, again the front is a, so this is rear, and q1 dot nq of q2 dot front a, so I'll get a here in the q1. While note of q2 dot is empty, q1 dot nq of q2 dot front, nq with a front q1, this q1 and q2. Then q1 dot 2 dot q2 dot dq, it means remove this one. Initially front is here, now the front is here, this is rear. Then q2 is not empty still. q2 dot q1 dot nq of q2 dot front, now this is front p, and remove dq, will remove this p. Now the front is pointing to the last, still it is not empty. Then in q1 dot nq, q2 dot front is moved over here, and q2 dot dq, now the q2 is empty. Okay, q2 becomes empty, the loop ends. So you have here this one. The slide before this, you mean from the beginning or this one? Question number 3, this one. Now q1 dot nq of q2 dot front. What is q2 dot front? This is front and this is rear. This is q2, this is q1. q1 dot nq of q2 dot front, front is a, so nq the q1 with a, This is A, right? Then the second statement, q1 dot nq of q2 dot friend. What is q2 dot friend? A. So A is again nq in q1. Okay, in the third statement, the same thing, A. Yeah, you can use add and remove. Both are same. It depends on the question what they give. Okay. In this slide, there is a loop. The loop start and the loop ends when the Q2 becomes empty. Okay. Now Q2 is this one. This is front. This is rear. This is your Q2. Sorry. This is your Q1. Q2 is not empty. Q1 dot NQ of Q2 dot front. What is Q2 dot front? A. A is NQ'd in Q1. Then Q2 dot DQ will remove A and move the friend to P. Clear? Good. Again it will go to the loop. Check Q2 is empty. Q2 is still not empty. It has again. Okay. Now here the loop will loop. Q2 dot is empty. This is your Q2. Q2 is not empty, right? Q2 has front and rear. Yeah, it is APM. So Q1 dot NQ of Q2 dot friend. What is Q2 dot friend? It is A. A is encoded in Q1. A is added in Q1. So you add A. Then Q2 dot DQ. DQ will remove A. The front will be now at P. Go to the loop again. Check Q2 is empty. It is not empty. Q1 dot NQ of Q2 dot front. Now the front is P. P is given here to Q1. Q2 dot DQ, remove P. Now the front is M. Now again check the condition. It is not true. It is true because it has the element. It's not empty. Q1 dot NQ of Q2 dot front. Now the front is M. And Q2 dot DQ, remove the element. Now the Q2 is empty. Go to check the condition. Not of Q2 empty will become false. Come out of the loop. Now you have Q1 APM and Q2 empty. Clear? Next, while Q2 dot front is not M, this is your Q2, this is Q1. While Q2 dot front is not M, Q1 dot NQ of Q2 dot front. What is front? A. So Q2 front is not equal to M. It is true. Q1 dot NQ of Q2 dot front, that is NQ in the front with Q2. Then Q2 dot DQ. Remove this and now your front is P. Again check the condition. While front is not equal to M, it is not M because front is P. Q1 dot NQ of Q2 dot front is P, NQ in the Q. Then DQ, Q2 dot DQ. Remove this one. Now the front is M. While Q2 is not equal to M, Q2 dot front. No, but it is equal to M, so it will come out of the next loop. While Q1 is not empty, okay. While Q1 is not empty, Yeah, it can be one element, then the pointer will be in the same for the same element. It is the front and it is the rear. Okay, the next loop is when q1 dot is empty is not empty, not of q1 dot is empty, q1 is not empty, true. q2 dot enqueue of q1 dot friend. Now start enqueuing the q2 enqueue of q1 dot friend. Your friend is here, this friend, this is rear, right? So add a here to the rear. Now this is your rear. Okay, then q1 dot dq, remove the q1. Now it is your front here. Then q1 dot is empty, it is not empty. q2 dot enqueue of q1 dot friend. q2 dot enqueue of q1 dot friend is p. Enqueue with the in the q2. q1 dot dq, remove this one. Now the q1 is empty, this condition become false, come out. Now what is your q? The q1 will be is an empty q, and the q2 is m a p. What is the output of the following operation if the stack and queue uh, S stack and Q and both initially are empty? What is the output of this one? So let us draw a queue and a stack. Let's say this is a stack S and this is a queue. Okay. Q dot add A. First it will add A. Now this is your front, this is your rear. Then q dot add b, add b. Now this is your rear. Q dot add c, add c. This is your rear. Okay. So here your front is a, rear is c. S dot push of q dot remove. Remove will remove the first element, that is a. A is returned over here. S dot push, push in the stack. This is removed. Now your front is B. Then S dot push of D. D is pushed into the stack. While Q dot is empty, not of Q dot is empty. That is, Q is not empty. After this, yeah. So while Q is not empty, S dot push of Q dot remove. It means Q is not empty, so push dot Q dot remove. Q dot remove will remove B and push in S. Now your first is here. Again it will check the condition. It will loop again, check the condition. It is not empty. Then again S dot push off Q dot remove. Remove C and push C in the stack. Okay. Now your Q is empty. When Q is empty, it will come out of the loop. It go to the next loop. While S dot is empty, not of S dot is empty. That is, S stack is not empty. It is not empty. It is true. System dot out dot print S dot pop. Now this is your topmost element, which is inserted in the last. Pop will remove the topmost element and print on this screen. So it will print C. Okay. Then again check the condition. It is not empty. Again pop the next element, that is B. Yeah, CBDA. Then again it is, the condition is true, pop the third element D. Again the condition is true, pop the A. Now stack becomes empty, it will come out. Your output is CBDA. Okay. This is another example over here. So I leave this example for you because there is no time. It's already 6 o'clock, and I have another class right after this. So I'll leave this for you. The example number 3. You can do this by yourself. Okay, just understand and the answer is also given. You can read it. Yeah, sure. Inshallah, I will send you the recorded the video. For M180, yeah, I have sent you a video of recursion. The unit before this called recursion. I have sent you a video link for this one. You can look over there. And if you have any doubts, anything you want to ask me on recursion, you can send me an email. Okay, I'll be happy to reply. Okay, then thank you very much for the day, and inshallah, see you inshallah in the next meeting.